Welcome to the deep dive. Today we're tackling a truly unique and, frankly, somewhat unsettling story, all based on publicly available information. It's the case of Albert Stevens.
Right, a man who completely unknowingly became part of a human radiation experiment during the really intense period of the Manhattan Project.
Exactly. And Albert Stevens, he was just, an ordinary guy.
Pretty much a house painter, originally from Ohio. But in 1945, his life just took this completely unexpected turn. He got a misdiagnosis, terminal cancer, they told him.
Terminal cancer. And that mistake, that diagnosis, set everything else in motion.
It really did. Put him on a path. About path none of us would ever imagine.
So our mission today, for you listening, is to really understand how this could have happened. What did they learn or think they learned? And what are the implications that linger?
Yeah, we want to pull out the key insights, maybe some surprising details, without getting totally bogged down in, super technical stuff.
And to really get it, we have to kind of picture the time, right? World War II, the Manhattan Project.
Absolutely. The pressure, the urgency, the secrecy, it was immense. They were racing to build the bomb.
And that context, that atmosphere, it really shaped everything.
Definitely. So to understand Stephen's story, you have to start with the element itself. Plutonium.
Which was pretty new then, wasn't it?
Very new. First synthesized, isolated, really, in the early 1940s. And then, boom, the Manhattan Project ramps up, and suddenly they need to mass produce it for weapons.
But they didn't fully know what it did to people.
That's the crucial part. Its effects on the human body were, well, largely a mystery, a big unknown.
So you've got this push for production, but also this creeping worry inside the project.
Exactly. Concerns were growing. By 1944, there had been some mishaps, some accidents, people working closely with it.
Contamination fears, like breathing it in.
Yes, inhalation of dust, even accidental ingestion. There's one documented case, a chemist, who accidentally swallowed a tiny amount of liquid plutonium chloride.
Wow. Just thinking about the uncertainty they were dealing with.
It's quite sobering.
Mm.
And detecting it inside someone, that was another huge hurdle.
Why was it so hard?
Well, unlike radium, which folks might know gives off gamma rays you can easily detect outside the body, plutonium mostly emits alpha particles.
Which don't travel far, harder to pick up.
Exactly. They don't penetrate skin. So the main way they tried to gauge exposure was by analyzing urine and feces.
Doesn't sound very precise.
It wasn't, especially because such a tiny, tiny fraction of the plutonium actually gets excreted maybe 0.01% per day, and often weeks after the exposure. So getting an accurate body burden, really challenging.
So facing these detection problems and, the safety worries, what did they do?
They started with animals. In 1944, they began tracer experiments, injecting small amounts into animals to see where it went, how it behaved in a living system.
Okay, makes sense. Animal studies first.
And then, in 1945, they moved to human tracer experiments. But the initial goal, is important to stress, wasn't really about long-term health effects.
No, what was it then?
It was mostly about calibrating those excretion tests, trying to figure out if we measure this much in the waste, what does that actually mean in terms of the total amount inside the person?
Ah, okay. So it was about refining their monitoring tools for the workers.
Primarily, yes.
Yeah.
For worker safety within the project itself. That was the main driver for those initial human tests.
Right. So, with that background, now we come back to Albert Stevens. April 1945. Approval is given for human injections at a few places,
including the University of California Hospital in San Francisco. And Stevens, he was selected for the test there.
Yeah.
Codenamed CAL-1.
And the reason he was selected, this is the part that's just staggering.
It is. He was admitted to the hospital, yes, but for a gastric ulcer. A benign condition.
But they thought it was cancer.
They misdiagnosed it,
Yeah,
tragically. They believed he had terminal stomach cancer. And that misdiagnosis was the sole reason he was chosen for the CAL-1 plutonium injection.
Just because they thought he didn't have long to live anyway.
Precisely. There's even a quote from Earl Miller, who was the acting head of radiology there. He basically said Stevens was chosen because they thought he was, quote, doomed.
Doomed. It's hard to even process that. Our assumption about his lifespan led to him being experimented on without his knowledge.
It really highlights how the pressures of the war, the secrecy, the unknowns about plutonium, how all that could converge into decisions that, looking back now, well, they're deeply troubling.
Yeah, individual rights just seemed overshadowed.
Very much so in that context.
Okay, so the decision is made, May 14th, 1945. What actually happened to Stevens?
On that day, he was injected with plutonium. The amount was 131 kilobecquerels, or 3.55 microcuries. It wasn't pure plutonium-239, though.
Oh, what was it?
It was a mix, mostly plutonium-239, the main weapons isotope, about 0.75 micrograms, but also a smaller amount, zero point 0.2 micrograms, of plutonium-238, and it was given as plutonium nitrate.
Why the mix? Does the 238 isotope matter?
Oh, it matters hugely. Plutonium-238 is much more radioactive per unit of mass because it has a much shorter half-life. Think about 88 years compared to 24,000 years for Pu-239.
Okay, wait. Shorter half-life means it decays faster.
Exactly. It releases its radiation energy much more quickly.
Hmm.
So even though it was a smaller amount of Pu-238 by weight, it delivered a very significant portion of his total radiation dose, especially in the initial years and decades.
So using that mix dramatically increased his radiation exposure compared to just Pu-239.
Absolutely. It was a key factor in the incredibly high dose he ultimately received.
And again, just to be crystal clear, he had no idea this was happening. He thought he was getting treatment.
He had zero idea it was plutonium or an experiment. He likely thought it was related to his supposed cancer, but it had no therapeutic intent whatsoever. It was purely experimental.
The lack of informed consent is just
Completely absent. He believed he was ill, receiving care for something he didn't even have.
Okay, so the injection happens. Then what? Did they operate on the supposed cancer?
Yes, they did perform surgery, intending to treat the cancer they believed was there. And during that surgery, they took tissue samples. Standard procedure, send them to pathology.
And that's when they found out.
That's when the truth came out. The pathologist examined the samples and no cancer. What they found was a benign gastric ulcer, just with some chronic inflammation.
Imagine being the doctors, the staff, getting that report back.
Disbelief, surely. Here's this patient. They thought he was terminal. They'd selected him for this secret experiment because of that belief. And now, after the injection, after the surgery, they find out it was all based on a mistake.
A mistake that couldn't be undone. The plutonium was already in him.
Precisely. The experiment was already underway, based on entirely false premises.
So what did they do then? Did they stop monitoring him? Tell him.
No. They didn't tell him he never had cancer.
Yeah.
And the monitoring part continued. After the surgery, for nearly a year, 340 days, they collected his urine and stool samples.
To analyze the plutonium excretion like they planned?
Yes. But how they arranged it is, it's another layer. The Manhattan District, the military part of the project, actually paid for this collection and analysis.
But they couldn't tell him why they needed the samples, right?
No. The cover story was that they were studying his remarkable recovery from his cancer surgery.
His remarkable recovery from a cancer he never had.
Exactly. And Stevens himself, he was apparently sent home and asked to store these samples. His son later remembered finding sort of unusual containers around the house, maybe in the shed. He was unknowingly storing his own radioactive waste.
That's incredible. Did anyone suspect anything?
Well, there's a mention that his sister, who happened to be a nurse, was apparently quite suspicious about the whole situation about his treatment. She felt something wasn't quite right.
And did the monitoring stop after that year?
The formal sample collection seemed to, but the connection with the hospital didn't entirely end. It seems like Stevens continued to get some follow-up care at UCSF, particularly for later gastrointestinal problems. And he apparently received free lab work during those visits.
And did they see any long-term effects?
About 10 years after the injection, yes. Medical notes started mentioning issues like spinal degeneration, deteriorating discs in his back.
Which could be related to the plutonium.
It's certainly consistent. Plutonium, like other heavy metals and radium, tends to accumulate in the bone. So seeing bone degeneration years later, it fits the expected pattern of long-term internal exposure.
And through all of this, for the rest of his life, he never knew.
Never told. He was never informed about the misdiagnosis, never told he was part of an experiment. His family genuinely believed the treatment he got back in '45 had somehow cured him of cancer.
So his family history, as far as they knew, included cancer.
Right. His son apparently filled out medical forms for years, indicating a family history of cancer, all based on this tragic concealed error.
So let's talk about the dose. How much radiation are we talking about over those years?
It's estimated that over the 20 years between the injection and his death, Albert Stevens accumulated an effective radiation dose of about 64 sieverts.
64 sieverts. How does that compare to, well, anything?
It's enormous. To put in perspective, the current annual dose limit for a radiation worker in the U.S. is around 0.05 sieverts. Stevens received, on average, about 3 sieverts per year.
Per year. So 60 times the annual limit for a radiation worker every year for 2 decades.
Roughly, yes. It's considered the highest accumulated radiation dose ever recorded in a human being from an internal source like this. Just an extraordinary level of exposure.
And how long did he live after the injection?
He lived for another 21 years. He passed away in 1966 at the age of 79.
And the cause of death, was it radiation related?
Officially, the cause of death was listed as heart disease, cardiorespiratory failure. However, receiving that level of radiation dose, particularly to the bone and liver where plutonium concentrates, it's impossible to think it didn't have a significant impact on his overall health throughout those 2 decades.
Even if it wasn't the direct cause listed on the certificate.
Exactly. It would almost certainly have contributed to health problems. And his story didn't quite end there. After his death, his cremated remains were actually sent for further study
Really? Where?
to Argonne National Laboratory and later Washington State University's U.S. Transuranium and Uranium Registries. They continued to analyze the distribution and amount of plutonium left in his tissues, contributing to radiobiology research.
So, data from his body continued to be used long after his death.
Yes. And later studies, like one published in 1975, that looked at all 18 people known to have been injected with plutonium during that era.
What did that study find?
It confirmed Stevens received the highest dose by far, particularly to his skeleton and liver. The researchers noted that the doses received by these individuals were certainly high enough to be considered carcinogenic, to potentially cause cancer.
Did they find cancers in the group?
Interestingly, the 1975 paper noted that at that point, no bone tumors had actually appeared in Stevens before his death, or in the other subjects studied, some of whom were still alive then. But the potential was clearly recognized.
So, this whole story, the injection, the misdiagnosis, the secrecy, how did it eventually come out? It was secret for decades.
It was largely unknown to the public until the 1990s, thanks mainly to the work of an investigative journalist named Eileen Wellsome.
Ah, yes, the plutonium file.
That's the one. Her book and her earlier newspaper articles, starting around 1993, were absolutely groundbreaking. She meticulously researched government documents, tracked down individuals who were often just referred to by code names, like CAL1 for Stevens.
So she really uncovered the human stories behind the code names.
She did. Her work brought Stevens's case, and others, into the light, sparking significant public attention and, frankly, outrage.
And how did the government react once this was out in the open?
There was a response. After Wellsome's initial reporting, the Secretary of Energy at the time, Hazel O'Leary, made public statements acknowledging these past experiments and the need to address them, possibly with compensation.
And didn't President Clinton get involved?
Yes. In 1994, President Clinton ordered the formation of a special committee, the Advisory Committee on Human Radiation Experiments, or ACHRE.
To investigate all of this properly.
Exactly. To conduct a thorough review of these historical experiments, understand the ethical lapses, and make recommendations.
So just to kind of wrap our heads around this, Albert Stevens, misdiagnosed, given plutonium without his knowledge because they thought he was dying, ends up receiving the highest radiation dose on record from something like this.
All stemming from that initial mistake, and compounded by the intense secrecy of the Manhattan Project during wartime.
And the absolute total lack of informed consent, not just for him, but for others involved in similar experiments at the time.
It really wasn't part of the mindset then, especially with classified materials like plutonium, which was referred to by code names even within the project. Civilians wouldn't have understood the risks even if told the code name.
Were there people within the project raising concerns at the time or later?
There were. For example, Dr. Joseph Hamilton, who was heavily involved in the Berkeley side of these experiments, wrote a memo in 1950 expressing ethical reservations, suggesting the plutonium injections had, quote, a little of the Buchenwald touch. So some recognized the gravity later on.
Wow, that's a strong statement.
It is. But you also have to see it in the context of the era. Using radioactive materials in medical research, even in healthy subjects sometimes, wasn't unheard of, though usually with different elements and one hopes different circumstances. But the plutonium experiments were unique due to the secrecy and the specific context.
So summing it all up, Albert Stevens' story is just this stark example of what can happen at the intersection of, well, medical error, scientific ambition, and national security pressures.
Unknowingly enduring that massive radiation dose, all based on a mistake in secrecy. It forces you to confront really difficult questions about consent, ethics, and scientific research, especially when the stakes feel incredibly high.
Absolutely. And that leads us to maybe a final thought for everyone listening. How do we balance that drive for scientific advancement, especially in times of crisis or perceived urgency, with the fundamental rights and dignity of individual human beings?
Right. And what responsibilities do governments, researchers, institutions have, even when they believe they're acting with good intentions or under immense pressure? Stephen's story doesn't offer easy answers, but it certainly compels us to keep asking those questions.
A sobering but incredibly important story to understand. Thanks for walking us through it.
Indeed. It's one that definitely stays with you.